Welcome to an overview of the Orchestrate Active Inference Learning Workbench. This was built and released in just one weekend, and as such, there are still some errors and bugs to be worked out. Most does seem to be functioning to my specifications, so let's do a quick run through here. First of all, credit and appreciation to Pezzulo Friston and Pezzulo and Parr and all their work for Active Inference and for the MIT press release that makes it possible to have access to all of this information and to be able to repackage it and reshare it with you in this way. I'm aiming here to create a workbench, a Lego-like experience, if you will, building with Active Inference agents. And thanks and credit to the creator of Jido, Jido, which means automation, which is a suite that is built on Elixir and Beam. And you'll see that noted here, which makes running active inference agents extremely attainable for nearly anyone. So here we go. Let's dive in. We have a learning hub where you could jump straight into specific exercises. I have all of the equations, at least I believe I have all of the equations for our active minimization of free energy, active inference here worked out. Each of the equations you can click on. That will get you to the source form verbatim. Symbols, conceptual role, implementation role, dependencies, and then for provenance, where that was pulled from the original source material. Back to our overview. You could jump into try examples or open labs, as I said. Equations. We also have model families then. So here you can browse each of the different type of active inference models. So we've got your, all right, and we've got our model taxonomy. So blink in there for a second. We've got our POM-DP. We have our variational free energy. Expected free energy, our hidden Markov model, partial observability, our partial, back to our, can't talk tonight, POM-DEM. We've got our derelict paratomized and continuous time generative model and hybrid. I'm still learning some of these terms, so stumbling on the pronunciation of the vocabulary as I learn myself as I build these things out. All right, and then also have overview of the architecture here, the way this workbench is built. The world plane and the agent plane are separate. And I've done that for a couple of reasons. One, to stay true, so that the agent code never exists alongside of the world code. The agent can never, in any way, shape, or form, see the actual world. It can only see the signals that we configure for the world to send out, and that the agent is configured to receive. I also built it this way so it's, in theory, architected to be fully extensible while I'm shipping it with an initial basic world, which currently is based on simple mazes. I do plan on iterating the world so that there's more out-of-the-box worlds, as well as I'm going to build a world builder. So you could then craft and architect your own worlds and then attach them here in the suite. Finally, by building it this way, in theory, I am also then able to expose the agent API, and or you could build any world and expose those signals back to the Jido agents, and you now have a fully extensible way to build, model, and run agents, and then attach them to any world that you might have available. All right, if we get into learn, we have 4 paths. I want the story, I want real world examples, I want the equations, I want the full derivation. This is setting essentially the vocabulary, reading level, and depth for all of the other learning modules that we have to follow. So if you are taking the high road, as they say in the book, you might just say, I want the story, and it's going to go a lot lighter on the math and specifics. If I want real-world examples, and that's going to go too heavy in the math, but it's going to start to connect with more analogies. And of course, if you want the equations, it's going to give it to you just kind of straight and dry. And if you want the derivations, it's going to take you through the proof sketches and canonical references. So let's just click in one or two here. Let's go, I don't know, into chapter 5. You can listen.
Welcome to chapter 5. Message passing
To the full chapter. You could chat about the chapter. We'll come back to that in a second. And then there's also a chapter 5 specialist. Within here, there's multiple lessons for each chapter. And if we go back one, you can also jump right to the workbench equation that's being referenced. And then it also shows what lab would be applicable. So again, if we go into this particular session, we can narrate the session. This is generating it on the fly. It's
the leaf propagation is exact on trees, approximate on loops.
That just generated on the fly using a local LLM here on my little desktop computer. So it went pretty quick for a short little message. If I want, I can show the book excerpt. It's in plain text, so it's a little rough to read. I can make that prettier, but it's there. And then if you want to see the figures, I do have clean excerpts of the figures that will then render. I also have generated a podcast.
Welcome to chapter 5. Message passing and neurobiology. This is where the book makes its sharpest commitment.
So depending on, again, how far you want to go, if you want to listen to the entire book, you can do that on the prior, or you can do the podcast option, which is a condensed presentation of the entire chapter presented with 3 different voices, so it's a little more conversational. Makes it a little more interesting to get through the material. And again, trying to make it accessible. So I thought the more modalities that I can layer in here, ideally without it getting too busy, then the more accessible or approachable it is by folks. So again, here you see the different treatments. If you just want the story, you want the full real world, the equation, the derivative. All right, from there, you can then open the lab. And here is one of our labs. I have not, again, I built this entire thing in one weekend from scratch, from an empty folder. So I have not been able to complete an extensive quality assurance cycle. Most everything at a cursory glance is responsive, I will say. I was going to say functional, but I'm going to say responsive. I need to prove and proof that it's all fully and actually doing the active inference calculations correctly, and I need to ensure that the UI is properly reflecting everything that is going on. But again, here you can see we did run and we got some validation there. So this is obviously one of the more complicated active inference because we're starting to get into hierarchical machines here and starting to layer in more depth. Everything can be edited. And again, I just need to prove that everything is taking effect the way you expect it to. Session log here for what happened, and then beat scripts. And then again, we've got story, picture of what's going on, equation, and derivation. So 4 different levels to approach the same information. All right, so let's just go back to learn for a second. So again, this is your kind of more traditional, take your flow through the content. Each chapter is broken into multiple sessions. Sessions have labs, and then we also have 7 standalone simulators. These are the same simulators and labs that are used throughout. Again, I've not had a chance to validate all of these, so here's a free energy foraging. You see, I've got to look around and see exactly where the buttons are on all of them, because they were built out a little bit differently. Let's see. There we go. One full descent step. Okay. Try our X gradient. Okay. It does seem that our UI on this one is responsive. I see our operators. Okay. And there we go. I'll move on to the next mission. All right. You can see I'm having fun because this is one of the first times I've been able to play with it. Switch audience. So here, if you want to, again, change the levels, and again, I need to prove that this is fully taking effect, but everything is wired in there to do that, some font changes, etc. I'd also like to localize this for multiple languages, so maybe somebody can help me with that. All right, so more labs. Let's see, Active Inference. Here's a, oops. Let's go, there we go. Let's see, so here we can send a message tick, and this one is simulating different gauges, noisy gauge, quiet gauge, etc. Actually, it was not the one I was looking for. Oh, here we go. Jumping frog. So we've got, I think we have more than, oh no, here it is. So we have more than one of these. So here we go. Observed sensations. It's green and jumping. Auditory sensation is croaking. In response to that, we have a high heart rate. And if we have a tactile sensation of wrinkliness, and the action we're allowing is touch. So those are the presets. I will then hit auto run. And we see our posterior has risen up. Our priors have all reflected that we're pretty sure that's a frog. However, what if it's quiet and smooth? Our posterior is now updating based on the new observations. We see something that's green and jumping, but it's making no noise. It's causing our heart rate to rise, and it's smooth. Maybe it's not a frog. Maybe it's a green leaf in the wind. So we would need another observation to really settle on if it was a frog. So we're almost 50-50 at this point. What happens if it's green, still quiet and smooth? Auto run, and as expected, if it's green and still makes no noise and it's smooth, well, it's really less likely to be a frog mathematically. And what do I mean mathematically? Well, if you're into active inference, you already know what I mean. But if you want to learn more, it's all right here in the side panel. And then we can play around with the base data as well. So why does jumping green cause our posterior to go up by so much? Oops, green and jumping, auto run, and we see our posterior is going to come back up. Why is that? Well, because we have said that jumping green is a high indicator of the presence of a frog. So the probability of it being a frog when given the signal input of jumping green is a high probability. So this lab looks to be working well, at least at that cursory evaluation. Okay, so to cap that off, that was the learning paths, and there's more labs down here to be explored. Guide, I guess I could have started here, and this is the guide for the overall solution. Here we have a quick start here. You could build your first agent, you could jump in and see 5 examples, or get into the block catalog. I've built in 50 runnable active inference recipes, so you can go from the guide to the cookbook. So here's your 50 recipes. Any recipe you can open. You can run this recipe in the builder. Fingers crossed it worked. I need to trace provenance and make sure that this is actually the exact agent that I just built, but when I was testing it before, it seemed to be loading correctly. So there is our agent builder. So if we wanted to, obviously just rearrange them, we could, but if we wanted to add a new perceive and then start to wire that in, this is not going to be a legit, but if we wanted to wire that in, we could. So we could take from a recipe, build a model, and then back to the recipe page, builder again, so it's clean. Make sure my artifact isn't there. Okay, so now we're back in builder. At this point I could make an edit and save it, or I could instantiate it. At this point now, I've created the live agent. So here are our startup signals, our agent state tree, and our provenance trace. No actions yet because we haven't done anything with it. At this point, we could open this agent in Studio or attach it to a world. Let's go ahead and open it in Studio. Looks like I still have some, there we go, navigate, new run with this agent, attach existing agent, and attach and run. Okay, so now we are in the Studio, which is an extension of the built-in world that I shipped. And if we run it, it's a pretty simple world, so the agent got to goal without much issue. So not a surprise there. We can detach it, keep the agent live, and move it to a different world from here. We can archive it, or we can trash it. I can look at it in the lifecycle panel or open it in Glass. If I open in Glass, I'll get a new tab. This is all the insight to this agent. So back to again to what you saw, it has quite a few more signals now. Then I can scrub the timeline. So I can rewind this agent to any point in its life and then have that data go back to its struct at that point. Okay, so let's go back to the guide. That was a quick run through the cookbook. Cookbook gets you to recipes. Recipes are pre-built agents. When you open a recipe, you can go to the builder and work with it visually and edit it. Once you've built it, you can save it, or you can take it into another lab, or you can run it in lab or run it in Studio. If you run it in lab, right now this is a bit more mature than Studio, so you have a few more worlds to pick from. I'm sorry, I was picking an agent spec. That's a bit deceptive. I shouldn't have messed with that. I just caused it to pick a different agent. That's okay. Picks an agent. You can pick a world and then create that agent in that world. So in this case, it wasn't. It didn't flow quite through from the cookbook because I touched the agent dropdown. But we will still then go ahead and run this one. So in this case, our agent spec is a POMDP maze agent, just a base agent built to navigate mazes. Again, we can open it in the Glass engine. It gives us a new tab, and you can see the Signal River update as the agent is working. And again, the agent and the world are separate. The Glass is an introspective of the agent, only reading. So you can see it's still trying to make its way around. It appears to be stuck in the corner at the moment, and that definitely happens at this stage of learning sometimes. So that will keep running. We don't have to wait for that. All right, back to the guide. And just some more shout outs here, Honest Surfaces. Again, this is all work in progress. Credits and references, technical references. You can open technical details, see the architecture, see the umbrella graph dependency. Again, this is all to be proven and validated. Configurations, etc. Hopefully I didn't just flash any secrets on the screen. Signals and events. All right. So then I showed you equations, so you can open and inspect any equation. There's the details, implementation rule, and where it came from. You can see all the models. You can go directly to my built-in world. My built-in world has pre-configured templates for agents that match with these settings. So you choose a world. So we'll pick our 7x6 with a deceptive dead end, and then we'll configure our blanket. So this is shaping what signals the agent is going to see. So I'm giving the agent the vocabulary of north, south, east, west. I'm going to let it observe the cardinal walls. I'm going to not give it a goal Q. I am going to let it know its tile position, a unique tile number if it wants, and when it hits the wall. And then we have some model parameters, planning horizon, policy depth, etc. Here I can create the agent and the world. Again, the agent and the world are separate, even though I'm painting them on one screen here, the data is completely isolated. So at this point, I can run, and our agent will get to work. We can see it navigating the maze. We can see its policy posterior by direction. We can see its marginal over policies, so its prediction of where we think it's going to go, where it thinks it's going to go next. And there she's navigating. We've got a more detailed projected trajectory. And then we can see our policy posterior top 5 update. And then here's our active event bus, which will match what we see in the glass view. And then here's our step history. So we're obviously still clicking up steps. And we've got a bit to go. Again, all this is just running locally on my desktop here. So Active Inference agents aren't very heavy on processing in this case, especially because there's not a heavy level of policy selection or reasoning going on at this particular example. Okay, what else could I show you? I showed you the world, I showed you the builder. I have a couple of built-in archetypes that you can drop in there. So there's a maze solver already built, ready to go. It occurs to me I don't know that I have a clear button, so I'm going to need to work on that. I don't have a way to clear the screen gracefully. And or you can pick each individual piece of a model and build out your pieces if you're at that level. And of course you can do both and start to layer it together. Start to layer it together. And then from here again, once you have a model, you can hit instantiate if you haven't messed it up like I just did. Oops. One more time. Oh, I have to save it. There we go. Don't know how to use my own tool. There we go. And now it's instantiated, and now we've got a live agent. Then we can go over to Glass, and in the time we've been playing around here, 20 minutes, I've built 4 active inference agents, and here they all are. So I can go back and inspect them and see what they were up to. I can rewind any of them in time, put them back to a prior. Let's see, it already? Yep, there you go. And then we can also open the details of any specific event and see what happened. There's our provenance tuple. Here's the equation that applied, the specific event, normalized latex, our symbols, specs, and family. And then this shows that I still have 2 worlds running. So if I want to stop this one, in theory it will clear off of the running. Yep, yay, it works. And I can go back and see this one. And see it paused when I navigated away, but I can come back and can I resume? I can step. Yep, okay, when I hit run, it resumes. So if you navigate away from a world, it will pause it. It will update the running queue, and then you can come back and resume any agent that was paired with the world. All right, I believe that covers everything. So again, special thanks to all the folks that make this possible, and very excited to see where we can go with Active Inference and taking the work that Pezzulo Friston has done and brought out, and the work that the Jido team has done and brought forth, and see if that together with my theory and approach to working with AI might just make active inference more accessible and building with AI more attainable for everyone. Thanks.